So we'll kick off and welcome you to the next in the Big Issues in Biodiversity Science webinar series run by WABSI. Today we're talking about forested ecosystems, carbon sequestration and the impacts on biodiversity. And it's great to have Martin with us all the way from Finland virtually to talk about forests and one of the interesting things about a state as large as WA is we have everything from the tropics in the north and the deserts in the interior to the Great Western Woodlands, some of the largest temperate woodlands on the planet, all within our state. So really interested to hear today about Martin's work globally in forest ecosystems. In opening this meeting, of course, I do acknowledge the traditional owners of the land that we meet on and the lands that we work on across Western Australia. I'm today on the lands of the Whadjuk Noongar people in Perth, and pay my respects to elders past, present, and emerging, and to the elders and traditional owners of the lands that you're joining us from today. Very important part of our work in WABSI is trying to really do justice to that ongoing custodianship of land and the privilege of working in a landscape that has been managed and cared for millennia. WABSI is a joint venture of 4 universities in Western Australia, along with 4 West Australian government departments, CSIRO and the West Australian Museum. We are established to facilitate collaboration on the big challenging problems and opportunities that are presented in the state for biodiversity. Our unique flora and fauna and our resource-based economy combine to give us a challenge and an opportunity unmatched elsewhere. And we exist in that space between community, industry, government, and researchers. The WABSI approach is to take a very end-user-led approach, understand the problems faced by managers and land managers and regulators, and really understand how research can meet those challenges and close the knowledge gaps. And we work through that process, starting from the end users, moving through into the research community to understand what is known that can close those gaps, and then developing research programs and prioritizations that are targeted at the remaining knowledge gaps, and looping back around to those end users to try and get better outcomes for environment, economy, and community within our state. If you haven't already, I encourage you to look at some of our many publications that have addressed these issues in the state of WA. So without too much more from me at this point, I'll introduce Martin Forsius from the Finnish Environmental Institute, joining us, as I said, from Helsinki in Finland today. And Martin, I'm just going to stop sharing my screen and hand over the floor to you for your presentation.
Oh, thank you so much. And I'll try to then share my presentation.
Perfect.
Can you now see it in the presentation mode?
Yeah.
Okay.
Absolutely.
Excellent. Okay. So, okay. Thank you so much for inviting me to talk today, and I hopefully can provide you with some useful information on the things that we have been doing in this context. So I will talk about how to combine carbon carbon sequestration and storage issues with biodiversity issues on the landscape scale, and what type of methods you can use to try to find sustainable solutions for these things. So as said, I work at the Finnish Environment Institute in Helsinki, and the Finnish Environment Institute is a governmental research organization under the Ministry of the Environment, and our task is then to help to find solutions to environmental problems, particularly on the national scale. But we are also working with in European projects, and also have some connections to this global work as well. But our main task is to work at national scale issues, and that's also my main examples will be from our national scale studies. We are working with the kind of very much project-based projects. So we are then receiving funding from various organizations, including the European Union. So I'll then go forward. So this is now the content, how I will make this presentation. So I will first give a short introduction on the background on the carbon cycle and climate change issues. Then some short words about biodiversity crisis on the global scale, and then how then one could identify these pathways for this change on the kind of general level. Then the main part of the talk will be I will show results from large-scale studies in Finland, then how we have actually tried to deal with these issues, and then I did finalize then with giving some concluding remarks on what we think we have achieved with this type of studies. So I will then start with this short background on these matters. So first about the global carbon cycle. So this is from a recent paper by Friedrichstein et al. About the global carbon budget, how according to the most recent data, how it actually looks on the global scale. If you look at the numbers, and the main point I want to make here is if you then compare the fossil emissions of carbon dioxide, which are about 10 gigatons carbon per year. If you compare that with the land sink, which is then around a little bit over 3 gigaton carbons per year, and then the main part of this land sink is then due to the main part of this is forests, and there is also a lot of data on the storage of carbon. So you can see that there is a big carbon stores in both vegetation and especially in the soils. In the soils it's a very large storage of carbon, and that's of course why this kind of land sink is so important also for mitigation climate change. But if you compare the numbers of fossil fuel emissions, then with the sink, I mean the land sink and also the global or the atmosphere, the ocean sink, you can see that there is not enough of the sink terms to compensate for the fossil fuel emissions, and that's of course then why we as we all know there is this global scale increase in temperature around the globe, and so this is just one example of a global temperature index, and as you can see that there is a very large increased during the last decades, and still, I mean, more than 1 degree Celsius is the global scale increase since the early 60s, and this is still continuing. And then, if one thinks about the mitigation, we obviously there needs to be something done about to mitigate the climate change. So this is then what actually should be done if we would like to achieve the net zero emission target, and according also to this global agreements like the Paris Agreement. I mean, how much the emission should be reduced, and also how the sinks should be increased in order to meet the global temperature targets. And the point here I really would like to emphasize is that, as you can see from this is kind of a generalized picture, is that there needs to be a very large increase in the carbon dioxide removal, and this has to be done both by then increasing and maintaining the kind of land sink terms, but also there is a very large need to increase this technological means to decrease the carbon in the atmosphere by various techniques, so carbon dioxide removal techniques. And this is, of course, an enormous challenge for humanity to actually achieve this. Then the other point I also would like to make is that there is a difference if you talk about net zero carbon dioxide targets, or if you are talking about including all the different greenhouse gases. So as you know, it is not only carbon dioxide that is causing the climate change problem, but there is also this non-CO2 greenhouse gases, so methane and nitrous oxide and these fluorinated gases, and this also causes a little bit confusion regarding the terminology if one talks about net zero carbon dioxide target, but or if it's a net zero greenhouse gas target. So that is then I mean, even more kind of removal techniques are needed since we really need to consider all the greenhouse gases. So there is even a more action than needed to get this net zero, and we also have to get on the long term to this on the negative side, in that we have to have more things than the sources of greenhouse gases, because there has been so much emitted already. So this is really an enormous challenge to achieve this. Then on a national scale, there is of course a little bit possibilities to go in a little bit more details. This is just an example now from, and I will come back to this later. So we like in Finland, we have very good numbers on the average carbon budget for forests and where it goes, and also these different terms, and including then timber removal from the forest that you can see here. So it's of course on the smaller scale you can go into a little bit more detail and have of course access to more data in this kind of context. Then, as we know, the other or one main real global scale issue is the loss of biodiversity, and this is just one example from a quite a famous paper by Pereira et al. And where it's shown how the increase in extinction rates of a species, how much it has increased from during the 20th century and even increasing during the 21st century. and there's then data on different biodiversity components, and but the main point here is really that if you look at the reasons for this species extinction, you can see that the main drivers are climate change and land use change, and of course their combinations. So this obviously there is a direct connection to I mean, compared to this carbon issues. I mean, where there is this land sector and land use change is a key component, and of course climate change then caused by this disruption in the carbon cycle is then also driving the changes in biodiversity. And this is the obvious reasons. I mean, so why there is so much connection between these issues is that yeah, well, again, I mean, like on the national scale, we again have very detailed data on also biodiversity, and for Finnish conditions, we have about 12% of the Finnish species are classified as threatened, and quite a large proportion of these species are actually from forested regions, about 70%. So again, also on the national scale, we have this close connection between this forestry and land use change and biodiversity issues. But then the point I wanted to make is that since there is so much a connection between these issues, there is an obvious need to look at combined pathways, how we could kind of mitigate both these problems at the same time, and then try to find these resilient pathways that really leads to higher resilience and lower risk for both biodiversity change and climate change. And that's really the task that we should do, and this is really what we have done, as I will show in for our Finnish conditions, how we have tried to identify these connections between these problems, and also the pathways, how we can look at these issues at the same time. So I will now go then to this actual example, so how we have dealt with these issues in our Finnish studies, and then the kind of reasons for or the policy issues that is the motivation then for this integrated studies, is that we have a kind of a formal target to become carbon neutral by the year 35, but at the same time then the land use sector has not been a sink, but instead a source in Finland, and also the growth of forest is decreasing. So there is a real issue then with the carbon sink in our country. Then at the same time, there is formal plans then to increase the biodiversity protection, also then by legislation from the European Union. There is a biodiversity strategy that aims at protecting 30% of the land area, and with 10% should be strictly protected. And we also have a proposal then for the Finnish Nature Panel that to implement this additional protection in forested areas, so that it should be this target should be reached equally in each administrative region in Finland. And this of course means then that there is a real need then to get this integrated evaluation of these targets, and if possible then even to find some win-win solutions in this kind of context. And we also have looked at then how these protection measures actually impact the carbon sinks and storages, and then also about the net greenhouse gas budgets from these different scenario combinations. So I don't have time to go into too much detail here, but this is just very briefly about what type of methods we have used to achieve this. So we have used different types of model systems, and so we have used a forest simulation model called PREBAS, which we have used to simulate forest growth and the carbon processes, and then used some different scenarios for forest harvesting. Here some examples are shown here. Then we have used a kind of zonation tool that for prioritization studies on both biodiversity and carbon, and I will show some examples of this also. Then we have also my institute has a model for simulating anthropogenic greenhouse gas emissions, and again we can use different scenarios to look at different energy solutions here, and then for we have also used a lot of empirical coefficients and data for other land use sectors, and the end result is that we have derived then this very detailed spatial data sets that we can use for this different evaluations and assessments that we have done for different ecosystems. And if you are interested in technical details, here there are these papers that provide you with more details on how this whole thing is built up. But very briefly, so this is really how we have tried to integrate this type of different type of information in this kind of integrated assessment framework. So then including then anthropogenic greenhouse gas emissions, then from emissions from other land use sectors, then this PREBAS model scenarios for forestry. Then we have this spatial biodiversity data and the zonation modeling tool. And then by combining all this information, then we have then possibilities to look at then the carbon neutrality target and also the impacts of different types of biodiversity protection measures by integrating all this data into this type of framework. And this is also described in a paper that's available. So now a first result from this kind of study. So we have then derived this detailed spatial data sets on net greenhouse gas emissions by land cover type. So this is for the present day situation, so this type of spatial data is then available for the whole country, and what we can do with this data is then since we have data on both the anthropogenic emissions and we have this data from all this land use sector, we can then look at the how far we are from the carbon neutrality gap, and so according to these data sets we have still we need to there is about 37% gap in carbon neutrality in Finland, and if you compare then the sink sector and compare with this emission sector, so there is still a lot to do on the national scale. We also have this data on different for all these administrative regions in Finland, so we can do this type of assessments also for each on going into larger spatial detail or for these different regions, which also have their own climate targets in this kind of context. So this is now an example from this kind of regional scale approach. So these are 4 different administrative regions in Finland, and so where we have combined this data on sources and sinks, and then for different land use classes. So the point here is really that there's a very large difference also between the regions themselves in how this situation looks like. So there are regions where we have very high high emissions of anthropogenic emissions due to industrial very industrial use, and a lot of people living there. And then we have other regions where this situation looks very much different. So this also means that the regions themselves have very different kind of starting point for looking into, or if they want to then reach their own climate targets. This is just an example from this forestry, more from this dynamic modeling. So again we can do it then by looking at the biomass removal and the forest growth. We can also look at this in a dynamic way and get data on how the carbon sinks in forests are then changing if we look at different scenarios, and so we can then get information on how the carbon sequestration and stock is changing in time in using different assumptions, including also climate change scenarios as well. So just one example regarding this development of the carbon storage of Finnish forests, and here the main point is really that there is a very large potential to increase the carbon stock in Finland. I mean that means to sequester much more carbon by reducing the harvesting. Forest harvesting is a very big industry in Finland. So if one would reduce harvesting so this could be used as one possibility to achieve to store more carbon in the forested ecosystem and to help them to reach mitigation targets in this kind of context. Then what we also have done is then we also have done a lot of work of collecting different types of biodiversity data on the spatial biodiversity data. So on both indicator species and then kind of data, of course, on we have used different types of indicators then like on the deadwood potential, which is then related to it's a good biodiversity indicator. So we have done this also put a lot of emphasis on collecting spatial biodiversity data and including then where all growth forests are located and so on. And then we also know where the forestry measures are located. So by combining all this data and we have all this carbon data, as I just explained, we can then by using this optimization, we can then look at where we have where the important areas are located both for biodiversity and carbon and different types of combination of these two issues. So this is just an example of how it looks like on the spatial scales for one area where we have developed these tools. So this is then just for one area where so we can then look at if you look at the important areas for carbon only, for biodiversity only, and then kind of balanced priority areas in the landscape where one could reach this kind of optimal solutions in this, and we can use different weights then on these different sectors if one wants to put more weight on biodiversity or carbon and so on. So these are just tools to make this type of spatial assessments on these combined priorities. We have also done this now since when we have developed these methods. We have then done this on the national scale. So we have these types available for the whole country, where we then I mean have identified these areas which are then in the same way. I mean we have for both biodiversity, then biodiversity carbon or carbon only, and then here one point is also to show that so that is there is a difference in how this kind of priority areas are located spatially. So because of climate, maybe for climate reasons, I mean we have more the most important areas for carbon storage and sequestrations are in the southern parts of Finland, because forests grow better here and we have better land. So this is also an issue is that there is a kind of a spatial mismatch between this also how we compare to where biodiversity is more equally distributed, these important areas in this kind of context. So there is again like a spatial considerations to consider if one wants to make this type of optimization in the landscape. Then I said, there is this kind of formal target to have these new protected areas in each locate them spatially equally in the region, and this is just to we have then identified how far we are from this 10% target in each regions, and you can see that there is again like a spatial mismatch. We have much more protected areas already in the northern Finland, where there is less people, and there would be a much bigger need to have more protected areas in the southern parts of Finland, and in order to reach this 10% target. So again, there is this kind of this spatial issue in how to deal with this kind of protection issues. What we then have also done, since we wanted to look at this kind of combined issues, is that we have looked at how I mean what is the current situation regarding the carbon sinks and the carbon storage, both at the currently protected areas in Finland, and if we would like to achieve this 10% target, I mean what that would mean for both the carbon sink and the carbon sequestration in the whole country, and there is a couple of points I would like to make here is that there would of course be if one would increase the protected area, there would be of course an increase in both in the carbon sink and the carbon storage on the national scale, but what is also interesting is that since we have also data on how this anthropogenic greenhouse emissions in Finland will develop, so according to this data, we depending a little bit on what type of measures would be done, like the scale is that we could by kind of having quite advanced mitigation measures for anthropogenic emissions, we could reach somewhere between 9 and 18 teragrams carbon equivalents per year of anthropogenic emissions, and if you look then at the carbon sequestration numbers from especially if one would increase the carbon or the protected area, they are almost the same of the same order of magnitude. Is that sorry? So that really means that there could be a good chance then if one would really increase the protected areas, that there could be like in this kind of situation like a win-win situation between the protection target and also to having a quite a large carbon sink and storage then to compensate for this anthropogenic emissions. So if according to these numbers, there really could be a like a win-win situation in this kind of carbon mitigation strategy. If one would then try to implement this kind of protection target in an optimal way. And then since we have data on also on how to locate this protected areas most efficiently, or by then maximizing biodiversity, one could really play around with this type of issues and try to really find a spatially optimized solution how to get enough of the carbon sink needed, and then like to then also achieve the carbon neutrality target. Then the final point to make here is that there is the kind of economic value of this carbon sequestration of the protected areas is also quite large, and because one can estimate this, get some estimate of this value is because there is a carbon trading mechanism in the European Union. I mean, where the kind of the companies can buy this carbon credits and on the market. So there currently the price is somewhere around 80 euros per ton of carbon dioxide, and then by assuming using this kind of numbers then for the carbon sequestration, one can then directly get some kind of estimate for the value of this ecosystem service of carbon sequestration, also in economic terms. So this number is then for the currently protected areas, and if one then would increase the protected area, then of course the number would also increase. So this is a significant, economically significant number then that one actually could then use or one argument for increasing the also the protected areas. Okay, so then I think it's time therefore to have some concluding remarks on what we have find, and so I hope I have been able to show that by applying this kind of spatially explicit model systems that we have used, it can assist in finding then feasible solutions to this quite complex interconnected issues, and as I also showed, that there is a very large difference in these Finnish regions then regarding both the greenhouse gas sources and sinks, and also this need for biodiversity protection. So this obviously implies that there is a big need for regional cooperation in this kind of context. Then our data clearly shows that you know, or I didn't really show this explicitly, but we have also shown that there would be a need to reduce the forest cuttings in Finland if one wants to reach this national carbon neutrality target, and this is of course an issue because forest industry is an important economic sector, so that there's also needs to be some optimization done in this kind of context, because this of course like is economically important as well. As I then shown at the end here, it is that these present and potential new protected forested areas are important carbon storages and sinks. And also this economic value is quite significant, and then it can be used as or evaluated also by having different scenarios for these protection measures. And I think it's pretty obvious that this type of integrated evaluation of both these climate and biodiversity issues is a feasible way to try to get feasible solutions for both problems, and also do this in a cost efficient measure. I mean, since we have this kind of spatial spatial data available and also economic data. So this is certainly is possible. But then finally, and obviously since this is a quite an complex issues and like a lot of uncertainty in many parts of including of course climate change and development as themselves. So there is a need to do further work on these issues and regarding both the climate related and biodiversity related topics as well. So if you then are interested in for further details, then we have a lot of papers published in that you can then get a little bit more information on this topic if you're interested. But I will stop my presentations here and I will try then to answer some questions if there is any. So and I'll then stop sharing. So thank you. Yeah.
Excellent. Thank you, Martin. That was a really informative presentation and we're beginning to see questions flowing in. So I'll try and summarize those into some points for our discussion and maybe start you off with one question. The regions were quite different in their levels of protection and their levels of greenhouse gas emissions. Is there any aim for sort of regional neutrality, or is it a national target that you're working towards?
Well, there is both a kind of a formal national target. We have even a climate law that implies that we have to reach this neutrality target then by 2035. And then many regions, they have their own kind of climate policies and they have like their own target. It's formulated in a little bit different ways, but so there is also an interest on the regional level to reach carbon neutrality as well. And of course then I mean if one wants to, or in order to reach the national target, then I mean there certainly needs to be development obviously on also on the regional level. So that there has to be some kind of harmonized aim in order to get to this national target as well. And this is of course what we are trying to help. I mean, since we have this kind of spatially explicit data, we are then trying to help both at the regional scale and the national scale to I mean both the regional administration and the national administration to provide the different types of data and information on both scales as well.
Yeah. And you mentioned that spatially explicit data, and we have a question which might be of relevance to a lot of our participants today around the type of biodiversity data that was used in the models, whether it was field data, point data, or remote sensing, and if it is point data, how do you extrapolate that then across the landscape?
Well, we have really tried to kind of aggregate all the type of very different type of data as possible, because that's of course a key issue in order to get spatial data on biodiversity. I mean, as we all know, it's quite a demanding task, and this is why we really have used all kind of the empirical data that we have been able to get also by citizen science data and on bird species and then we have also used different types of proxy data. For example, I mean the deadwood potential. I mean that, as I showed, which has then been derived by different types of modeling exercises. So because and then by combining then this kind of empirical data and this proxy information and also remote sensing based data, we are then trying to get this as good spatial data as possible. I think it's pretty clear that we have better spatial data on carbon issues than biodiversity. I mean it is a bigger challenge to get good spatial biodiversity data than for carbon data. I mean that's at least our national experience in this context. So.
Yep. And in terms of that carbon data, you've got some of your scenarios that you looked at included different levels of harvest, and you had carbon storage, standing stock biomass, and carbon storage in the landscape. Did your models with harvest scenarios take into account carbon storage in timber products, for example, structural timbers, which are there, or once they were removed from the forest landscape? Was that removal?
Well, we have in this data that I have showed, this were only using kind of we actually had data on how much harvest was removed from the forest, and so we didn't include this kind of timber product data in this data what I was shown here. But we have other groups in my institute. We have a large group that deals with this kind of integrated analysis. I mean, where they are really looking at this kind of really kind of product-based I mean evaluations. I mean using this I mean where you also include the kind of long-term storage of carbon and you know how the products are used and what their emissions are then caused in the longer term. So we have possibilities to go into this direction, but we have this is one of the things that we should improve in and one uncertainty that we in our present modeling tool is to really go into this kind of LCA type of analysis. So.
Yep. Yeah, and another question that's come through relates to those 10% targets that you ran in the modeling, and whether Finland is aiming towards a 30 by 30 sort of CBD target now, and whether you would be rerunning scenarios into the future with a higher protection threshold.
Yes, we should certainly do that, and because that it is I mean as I showed you, I mean it is also like a formal target, and that's certainly causing us a lot of controversy on the national scale, because there is I mean obviously competing interests in regarding these land use issues, and including the forest industry. I mean, which is it's a very big economic factor. So this is also discussed on the political level. You know what the you know how to implement this and there is like also a new EU policy on restoration. I mean there are kind of formal aims to have more restoration of ecosystems that they need to you know to enhance the degraded ecosystems. So this is one additional dimension that also this restoration measure should be planned and you know in order then to increase connectivity and between areas and or protected areas. And so there is a lot of this kind of spatial issues that have to be considered, and especially then for implementing the biodiversity targets. I mean, in this kind of context. So that's of course one kind of difference between this kind of climate related things and biodiversity is that as you know, regarding the carbon targets, it doesn't matter so much. I mean, how you locate them spatially. I mean, so biodiversity is of course more more spatially explicit. I mean, where you have the really valuable areas and like so carbon issues are in that way. I mean, a little bit easier to deal with since they are not so spatially dependent of where you actually implement these measures. But for biodiversity, it's of course a very crucial issue. So.
Yes, and that spatial differentiation and that slide you had with the carbon prioritized regions in the south with the longer growing seasons and sort of petering out towards the north, but of course the biodiversity being much more distributed across the whole country. And in WA, it's probably more water that's driving those growth patterns. We don't have the long Finnish winters to deal with, but we do have long droughty summers. So yeah, that optimization of spatial needs for biodiversity versus the climatic window for the vegetation in your carbon sequestration. In terms of decision making, from your perspective, do you think that obviously there's the economic driver for that, and you highlighted the economic value of those carbon offsets, but are you seeing biodiversity or climate as being the most influential factor in making decisions at that landscape scale?
Well, they of course are key drivers as well. I mean, we of course have also the agricultural sector that is has importance, especially in the south. I mean, where we have like the most of the agriculture is for climatic reasons is located in the south. So that's of course is also an important factor to consider. Not so much then for I mean, there's some connections to, of course, to carbon issues as well, but then the like so that but I mean and then of course the I mean, we have urbanization. This is also an issue. I mean, people are concentrating more and more in the south, and so there is a growing demand on land. Then simply for people moving in and there's more kind of land use simply for people living there and this kind of urbanization development. So there are different types of pressures and in different types of regions, and this is really makes things pretty complicated also.
Yeah, and wrap up with probably one final question, which is probably almost impossible to answer without knowing what Australian data looks like and thinking about the technicalities of your model. But we did have a question around whether the models are open and robust enough to be transferable to different landscapes and different data sources like the Australian landscape context.
Well, I think most of our models are kind of pretty specific for our regions, but then like for example, this kind of zonation approach. I mean, I know it has been actually used in Australia as well. I mean, it is. But like for carbon issues and so on, I mean, you certainly have your better national scale modeling tools and like so I think it is more the kind of what might be more useful for you is more the approach and way of thinking. How to deal with these issues and that's also why I didn't want to go into too much of these technical details. I mean, since I think it's pretty obvious that you have better national scale data sources and tools, and so which you can use if you want to do this type of evaluation. So I think it's more useful to look at how we have approaching these things, and then like then you should develop, which you of course are doing already, but but that might be the more useful thing for you to have a look at if you are interested. So
Absolutely, and I think that's a really really valuable point of looking at the approach and the integration that that you've been able to do between those carbon models, the climate models, and the biodiversity models, rather than the specific mechanistic aspects of the models that you have versus the models that are available in Australia. Thank you, Martin, for what's been a fascinating presentation, and I'd like to just take a moment to ask our participants to jump online and complete the survey, which helps inform us on how this series is going, and targeting some topics for the future. The next in the Big Issues series will be coming up on the 13th of August, looking at effective and ethical conservation, so learning from Indigenous and traditional knowledge. So we'll have some international speakers and a panel discussion in that format coming up in August. The recording of this session will be made available through our website. And thank you everyone for your participation, your questions, and Martin, thank you again for your presentation.
Yeah, thank you so much.